So today we are going to solve this question, maximum sum increasing subsequence. So this is the problem series from DP, dynamic programming. So let's see the question. So given array of positive integers, find the maximum sum subsequence of given array such that the integers in the subsequence are sorted in strictly increasing order. Okay, so in this problem we have to find a subsequence, right? Not a subarray, it's subsequence which has increasing elements or elements in ascending order, and their sum will be maximum, right? So what is the difference between a subsequence and a subarray, right? So in this array, if I say, so this 100, 1, 2, 3, this is a subarray, right? So this array, right, 1, 101 and 2 is a subarray of this whole array, right? But what is a subsequence? So sequence could be 1 and 2, 3. This is a subsequence of this array, right? Or subsequence, you can say it as subsets of a set. How many subsets are possible? Not subsets, it's also not true. Like how many possible number of permutation combination are possible from a given subset, right? So in this question we have to find the maximum subsequence, maximum sum subsequence which has elements in increasing order, right? So what should be the approach? Like since we have to calculate the subsequence, so we know that there will be some recursion, right? We have to do some recursion, we have to do some tasks repeatedly to get the answer. So let's do it, right? So we set an answer to 0, and then we traverse to the graph in the vector itself, right? Array dot size. Now what we have to check? We have to assign this answer as the maximum answer of the function that we solve for the uh, indices, right? Like the current index is I and the vector is array, and we return the answer, right? So what would be my function, right? Solve function. Now int this I index and this vector int this array. Okay, so in this solve function, or in this recursive function, what we have done, so we have passed an index, right? We have passed an index and the vector itself, so that we should know that okay, this one is captured. Now we have to get the subsequence including this one, right? So recursion of, it's a good theme. We should change the theme, I think. Okay, chodo. So in this recursion we have the function index with this array, right? Okay, so now we have to find the maximum answer, right? So what is my current answer, or what is my current sum? Current sum is array of I, right? My current sum is array of I. Now I have to maximize this sum, right? How I can do it? By traversing the array j equals to I minus 1 to j greater than equal to 0, minus j, right? And if that array of j is less than array of I, then we can say okay, this is a the next element is bigger than the current element, so we have found a increasing subsequence, right, or increasing order here, right? Now we calculate this sum as max of sum comma arr of I plus the solve function from going from j to array, right? And then return the sum, right? What is the sum? So what I have done here, so now we got this one, right? Solve for I equal to 0, we are at this position, right? So now we got the sum for this. Okay. Okay. Then after this, when we go to this I, right? So maximum of answer equals to max of answer 0 comma solve 0 comma error, right? So 0 comma error. So sum is error of 0. Sum is currently 1. So now if I go to this loop, okay, so this loop says that we have to traverse from I minus 1 or 0 to I minus 1, right? So there is no I minus 1 right here now, right? Since I is equal to 0. So since there is no I minus 1, so we will just traverse the 0th element and we will return back the sum, right? So sum is now 1. So max of, so I will write it as example max of 0 comma 1. So it's 1, right? Now if we go to the next index, right, I equal to 1. So solve for 1 comma array, right? So 1 comma array in sum is error of 1. Error 1 is 101, right? So this is the sum. Now j equals to I minus 1 to, sorry, from 0 to I minus 1, right? So like why we have set this like decreasing for loop, right? Why not some I equal to 0 to n, right? Because in that case then we aren't able to find a subsequence, proper subsequence, including the current element that we are processing, right? Okay. So so right now we are at first index, right? So this is 101. Sum is 101. Now we'll go to j from 0 to I minus 1, which is 0, right? Since I is 1, so j is equal to 0. And if array of j is less than array of I is this 1 and j is this 1, right? This one. So if this is so this element is less than 1 is less than 101. So okay, it's fine, right? So now we will assign the sum as max of sum and array of that solve of j. From j we will solve the rest of the part, right? That's why we are doing recursion here. We are backtracking the elements to find the subsequence which has a sum, okay, which is the largest sum of increasing with increasing elements, right? So okay, so this is the problem, or this is the code, right? So this is the naive approach that I have done for this, right? So let's see if it runs or not. Okay, so it ran. I'll try to submit it. Okay, so now your program took more than expected. So there's a time limit, right? So now this approach that we did is like what if there are what if the size of this array will be so big, right? So we have given that constraint should be within this limit, right? 1 to 10 power 3 array of size and array of I value is this. These are the constraints, right? And also you can watch a video on YouTube like how to know that which data structure to use by just seeing the constraints, right? Although this is not a very practical approach, but okay, for some of you who don't still know like how to approach a question base, which is like what the question is asking us, what data structure we should use, what approach we should go for, like in that case then you can directly look at the constraints. If there is a certain limit, right, within this limit that this algorithm will be optimal algorithm for you, right? So there is a video on YouTube that you can check out, right? So right now it's this problem is not working, so what we can do is we can go for DP, right? The series that like the question which is asking is related to DP, right? So we will create a DP first. I will create a size, right? Now we need to create a DP. We create a 2D DP, right? DP and comma vector int. Now what would be the DP size, right? What would be the dimensions of the DP? So right now we have this index, right? We have this array, right, going. Only 1D array is there. So we are creating 2D DP. how we can create it, like n cross n? No, right? Because uh, this is the number, and again, if I use the same number, like since if I created for square matrix, right, then in that case, the I pointer will always be set to this 0, not another one. Okay, so what is the next case that we can? So what will be the value that we will insert here, right? So the value that that we are expecting is like, okay, so if I use the square matrix, then what is the possible answers I may get? I may get this one, right? So if I use it as n here and set it to -1, and then uh, in that case, if I return the solve function with what we will pass in that solve, right? Array with the dp, with the starting index, and with the previous index, right? What is the previous index, right? I mean that we have to calculate the increasing subsequence, right? So for that case, we need to create a previous index to check if that previous value is less than or not from the current value, right? So in that case, we can't create a n square matrix. We have to, we can create a square matrix, but since this is a -1 index, so we have to initialize it as n plus 1, right? So now the mathematics part is done. Just copy this, get the arguments, right? And I will say it as j, right? So, okay, I will remove it. Now what's the base case, right? If we solve the dp, if we solve the 2d dp, then in the end case we have set all the rows and columns to -1, right? And if that row and column is not equal to -1, then in that case we have to return the answer, right? We got the answer. Then in that case, dp of I of j plus 1 is not equals to -1, then we have to return the answer, right? dp of I and j plus 1, right? Okay, so this is done. Now what is the next case? What is the base case, right? Base case would be if I reach the end, then I don't have to compute any other thing, right? So now the sum will be 0. So int not, okay, so if that I equals to arr dot size, right, then it will return the 0, right? We have reached the end. So now there's nothing going back and nothing going front, so we have to return the 0 as it is, right? Now this part is done. So we'll go back to next thing. What is that next thing is, we did not even traverse the whole array, so that we can, so in that, what elements we have to choose, we have not decided it, right? So I will create two variables, right? Pick, not pick. So pick, we set it to 0, int not pick. If we did not pick the element, then we go to the next index, right? Simple. Why this pick and not pick? Because since we have been asked to get the increasing subsequence with the maximum sum, right? So in this case, like there is this case, there is also uh, this whole thing, right? And increasing, if we are asking for increasing, then this one is the possible answer which sums up to 102. This one is an answer 2 300, like this is 105. This is so obviously greater than 0. But if I include 1 here as well, 1 and then 2 300, so it will be 106, right? So that's why output is 106, not 105, because we have to get the highest sum from the given array, right? So that's why I'm choosing pick and not pick. In that case, if I will drop this value, right? 101, if we do not pick it. So if we do not pick it, then we will go to the next one, that is 2, right? So dp I plus 1, and the previous will remain same, and if that array of I, right, or array of previous, not previous, sorry, set it to j, right. If array of j is less than array of I, and this is the condition that we are looking for, right. So we've set the pick to what, we have to get the sum as well, right. The array of I plus solve when is equal to solve error dp. What is the, if we pick the element, right, if we pick this 101, what we go for, the what we then search, we will search the rest of the things, right. So what is the previous and the current index in that case? So we'll go to I plus 1. Okay, that's fine. What is the previous will come to I, right. Previous will come to I, right. And now we will return the element dp of I j plus 1 equals to max of pick not pick, right. So this is the case. Let's see if it's run or not. Okay, it's running, right. Try to submit it. Okay, so it's submitted, right. So now this was the question that we have done, right. And then now with picking not picking, you have understood, right, when to pick and when to not pick. And also there's one case as well, right. If what if the pick is still 1, because I have set the not pick, right, sorry, j, I have set the j to -1. Initially it will be -1, right. We have to pick the current element uh, if we don't want it to, right. We have to pick it anyhow. That's why this condition as well. This will also run, right. I think this will run because we have to pick it anyhow, right. Yeah, it's running, right. So yes, we got this code and we have understood the question that maximum sum increasing subsequence. Like this is the typical DP graph question, right? Or DP question, I would say, because in the DP we will mostly play with subsequence, subarrays, and that knapsack problem is also a subsequence problem, right? Then there are so many problems, other problems related to this, like maximum subarray and those substrings matching, right? So these are the typical DP problem that you should practice to get a base hold on DP, right? So okay, that's it for the question. If you have understood this question, it's very good for you. And if you have not, then you can mention any doubts in the comment section. I will try and read it. And in very in the meantime, just uh, go and solve this question. Solve this by yourself. First do the recursion part, then do this. So right now I have done this. Memoization part, right. So tabulation part is like it's a homework for you, right. So you will do the tabulation part, and yeah, that is it for this video, right. Thank you.